Okay, so we've got another double displacement problem here. I'll just rewrite this. Okay, so what we're going to do is we're going to see that the PB will join with the OH and the Na will end up joining with the NO3 over here. Now here's how we work out the charges on each thing that's going to form compound A and B. The first thing we'll do is we will write this out, so it'll be PB and then there's going to be 4 NO3s over here. Now we can see that because we've got the 4 on the outside of the NO3. Now we know that each NO3 has a -1 charge. We can get that off the polyatomic ion chart. That's going to be -4, which means to match that we're going to have +4, which means the lead will have to have a 4+ charge as well. Now down here we've got the sodium hydroxide, and it'll be Na and OH. We know that OH has a -1 charge, and that means to match that, that'll have to be +1, which means the Na will have a positive charge as well. Okay, so that's how we're going to figure out our ions here. So it'll be Pb4+, NO3-, Na+, and OH-. And I'm not sure if this is the order, but these would be the answers to each of those. Alright, so that's all those. Now what we're going to do is we are going to put them together and see how we come up with those compounds A and B. Alright, so just continuing on with the problem then. We'll take the Pb4+, it will join with the OH-, and again we're just taking one of each over here to do this, and then we've got the Na+, and it joins with just one of the NO3-. So you're only ever going to take one of each ion over to the other side here in order to figure out what the compounds are going to be when they join together. Okay, so we've got these here, so we can now go ahead and put them together. So I've got Pb4+ and OH-. The question I'm asking myself here is how many of these do I need to balance out the charge on the lead? And I'm hoping you can see that it's going to be Pb, and you're going to need 4 OHs in order to make that balance out. Over here you've got Na and NO3, and those will just join together 1 to 1. After we've done that, we can then go ahead and figure out the balancing, and you see we've got 4 NO3s here, so I'll put a 4 in front of this. That gives me 4 NAs, so I'll put a 4 in front of this. That's going to give me 4 OHs, but that gives me the 4 OHs I've got here. Now the leads look okay, so that is now officially balanced. The last thing we can do then is look at the solubility chart. We'll figure out that this one's a solid and that these guys are all aqueous. Alright, so that allows us to figure out how we get compounds A and B out of all of this.